All right, so what we're going to be focusing on today, we're going to be focusing on some question 6. So the question 6 is, these are the questions that revolve around measurement. So the first thing that we're going to do is, I want y'all to try to attempt to get the answers to the first question. Determine the value of angle OPQ. So we have this shape here, and it's a cross section of a play area in a park. So PQRS, so PQR and then S is a rectangle, and PMQ, so P to M to Q, is a semicircle. OE is the midpoint of RS. So we have O here and then RS. So O is the midpoint of RS. And OP, so O to P, is 15 meters, and OQ is also 15 meters. So this line here indicates that they are the same length. All right, so that is something good to know. So here is 15, also here is 15. And they say the angle POQ, so POQ, and remember, the center letter represents where the angle is. So PO, so the angle at O that is enclosed by P going to Q, passing through O. Okay, so that is 40 degrees. Now they said to determine the value of angle OP, then Q. So the angle OP, then Q. So what is the angle here? So I want you guys to try work that out, then we'll go through it together. Alright, so let's go through the first question. So the first question, it says, determine the value of angle OPQ. So that means you're looking at an angle going from O to P to Q. And since P is the center, that means that we have the angle here that we are looking at. So right here is our angle that we want to get. Right here. So anytime you see the letters like this, OPQ, they tell you this angle. We're looking for the angle at here in the center that is enclosed by O and Q. So you see OPQ, that's the angle we're looking at. Now, we learned something very important earlier about this question. So this particular question, it has two lines that are the same. So here and here represent 15 meters, sorry. So here's 15 meters. Here's 15 meters, and it's indicated that here and here are the same length. So that means they are isosceles triangle. Now, an isosceles triangle means that if we have here and here the same length, if the angle here is 40 degrees, that means that the angles here are the same. So the angle that we have here and the angle here would be the same. Now, all angles in a triangle add up to 180 degrees. So all we need to do is figure out what's at 180 degrees. So you say 180, take away the 40, and then once we do that, we know that the answer, which is 140, needs to split evenly between these two angles. So if we have 140, 140 divided by 2 would give us 70. So we know that here is 70, which is what we're looking for. But also, bear in mind that here is also 70. So anybody got that? Alright, so try the next one out. It says calculate the length of O to R. So they want to know what the length from O to R is. Let's see what you guys would get if you try to calculate O to R. What would you do in this instance? You have a length here. You also have a length here. So this length here is 15 meters, and you want to find this length. So we did this, a question similar to this, a few days ago. Let's see how you guys will come up with OR. Alright, so anybody got it? Anybody could tell me what they did to get that? Oh, he's still working on it. So this is a trick here, right? If you look at this, OR is here, right? Now the cool thing about this OR, this is a semicircle, so technically what they're trying to do is to get us to calculate here the radius of this. Okay, now I know what OR is in the sense of I'm trying to find this. Now I know that this length here is 15 meters. From here to here is 15 meters, and I know that here is 14.1. So now, this here forms a triangle, which is a right angle triangle. So if I was to put this over here now, breaks it down to simple trigonometry. So we have 15 meters here, okay? Make this more look like a... And we have 14.1 meters here. So then over here is what we are trying to find. Now, since it's a right angle triangle, I could look for two things to help me. I could either use Pythagoras theorem And I can do that because I have two lengths. Or I could work out the angle that's here and try to work it out as well. And if I do that way, I would use SOHCAHTOA, right? Or sine rule or whatever the case is. Now, in this case here now, I know that this represents C in the Pythagoras theorem formula, which is actually C squared is equal to A squared plus B squared. So C squared, so this is C, hypotenuse. This is the hypotenuse. So this here, I could call this A, I could call this B, doesn't matter which way. So this is A, this is B. Now if I put that into the equation, I will replace the C with 15 squared. So I have 15 squared is equal to, and then I could put here A squared, which I don't know, plus B squared, which is 14.1 squared. Alright, so now I can work this out. So 15 squared, so I could say 15 times 15, which is 225. So I could put here 225 is equal to A squared. Now I need to add this to 14.1 squared. So then I could go 14.1 squared, which is 198.81. So plus 198.81. Now the trick is to get the A squared by itself. So in order to get the A squared by itself, the problem that we have here is a 198.81. So we just need to subtract both sides with this. And that would allow us to eliminate it on this side over here. So therefore we'll get 225 take away 198.81, which is equal to A squared. Alright, so now with this information I can work this out now. So 225 take away 198.81. So then I get 26.19. So then here I could say this is 26.19, which is A squared. Now the trick is, since I want to get A by itself, I need to square root it now, because that's the opposite of squaring a number. Square rooting it. So the square root of 26.19 is 5.12 basically. So since I have 5.11 here, the 7 is more than 5 and equal to 5. So because it's higher, I round this 1 to 2. So 5.12. So I can say here 5.12 meters. So that's the value of this right here. 5.12 meters. So here we said the angle is 70 degrees, and here we could say it's 5.12 meters. Alright, so what I want you all to do now is try to calculate the area of the shaded portion of the diagram. Notice we have two different shapes going on. We have a semicircle and we have a triangle. So let's see how y'all work this out. Alright, let's go through it now. So it says calculate the area of the shaded portion. So the shaded portion is this right here. Okay. Now we look at part B. It says the area of the shaded portion. This is this here. Now we need to figure out two things: the area of this triangle and then the area of this semicircle. Now the good thing is the question before allowed us to calculate the area, the radius of this semicircle. Okay, so area of a semicircle, we'll do that part first. So let's say we have a semicircle here. So here to here is 5.2 meters. Now usually the area of a circle is pi r squared. Now this is for a full circle. Now, as you can tell, this is half of a circle. This is not a full circle. This is half of a circle. So half of a circle, there's a formula that we usually would put, which would be the sector or the proportion that it represents. So it's 180 over 360, which is essentially the same as a half. Why did I say 180? This is a straight line, and a straight line is 180 degrees. So the angle of this sector here is 180 degrees, or half a circle. Alright, so if I was to work this out, I would end up saying 180 over 360 or half times pi. Now the thing is, for this question they gave us a value for pi, which is 22 over 7. So we're going to use what they gave us. So 22 over 7 multiplied by radius squared, which is 5.12 squared. Now, if you have a calculator that has fractions, perfect time to use it. So you can put it in just like this. So let's look at it here. So you have half times 22 over 7 times 5.12 squared. So our answer for that area is 41.19. Okay, 41.19. So that proportion here, right here, is 41.19 meters squared. That's 41.19 meters squared. Now the thing is, we need to figure out for this triangle. Now usually when we do a triangle, we use half base times height. In this case, they gave us an opportunity where we could use sine as well. So I'll show you using the regular half base times height, and then we go from there. So this is a triangle here, was with the base times perpendicular height. So based on this, the perpendicular height is 14.1, and because here is 5.12 and here is 5.12, that full base here would be 10.24. So if you use that area, it's going to be half base times perpendicular height, and the perpendicular height is a part that forms a right angle from the base. So if you could see the straight height here forms a right angle to this base. So half base times height would be half times 10.24 times 14.1. Okay, so then now once we work that out, this is what we gonna get, 72.19. And once we add these together, that'll give us our total area. So our total area will be 72.19 plus 41.19, which gives us 113.38, and that'll be meters squared. Alternatively, we could calculate the triangle using the sine concept of it. So half AB sine C. So the angle in here is 40. So the length here is 15 meters, and here is also 15 meters. So this C is a capital C. Here's a common C. So that means here has to be A, this has to be B. So then we'll have half times 15 times 15 times sine 40. And once we work that out, we get 72.31. So that would have been the alternate way of getting the length of this. So you see it's still, if you look at this, you see it will be slightly off, and that would have come from rounding and all that kind of stuff. Alright. Alright, so let's go through it now. So to find the perimeter of the cross section, so let's put this answer here. That means we have to find the full distance straight around. Okay, so from here, go around here, straight around. Now we have some of them already. So here we already know that here is 14.1. We know that these here together will be 10.24. So because we have a 5.12 and a 5.12. Here is also 14.1 meters. Now what we need to figure out is this here. So PMQ. So this straight around here is what we need to figure out. So PMQ. Now this here is a semicircle. Alright, so that's a semicircle. So to find the circumference or distance around a circle, we usually use 2 pi r. So 2 pi r. Okay. However, similar to what we did for the area, if it's not a full circle, then we have to consider what that section represents. So this section is 180 degrees out of a full circle. So 180 out of 360. So in other words, it's like we're saying half of whatever we get for the circumference of a circle. So in essence, we'll end up with half times 2 times 22 over 7 from our pi here times the radius, which is 5.12. Alright, so once we work that out, we will get this. So half times 2, so obviously this is going to cancel out, times 22 over 7, and then we multiply that by 5.12. Okay, so that's what we're working at as. So once we do that, we get 16.09. So 16.09 meters is the distance of this curve here. So 16.09 meters. So then now I could add up all these lengths. So 16.09 plus the 14.1, and the 14.1 came twice. So we got 14.1, 14.1 plus these two together, which is 10.24. And that would give us our perimeter, which is 54.53. So 54.53. Alright, so 54.53 meters. That's our answer. So that's our answer for that one. So answer for this one. Alright. Does that make sense?
Yeah, it makes sense.
Alright, so if you don't have it, you could take it down and then we'll try next one. So you're looking at this question here. So it says a piece of wire 61 centimeters long is bent to form a sector. So this is a sector, and we're saying that all around this is 61 centimeters long. The sector of the circle OPQ has center O and a radius of 18. So here's 18. We know these lengths, or we could work out these lengths rather. Show that the value of x is approximately 80 degrees. Let's see what y'all will come up with. That's correct, for another year. So this is January 2025. So what we just did was May 2025, and this here now is January 2025. Alright, so let's go through it. So it says this full wire here is 61. So straight around is a perimeter. Now here is 18. Here also has to be 18. So here is also 18 centimeters. So what that leaves me with is, if this is 18 centimeters and this is 18 centimeters and my perimeter is 61, I can say 18 plus 18 is equal to 36. Now if I say 61 take away 36, that would give me my answer for the length of this guy here. So 61 take away 36 is 25 centimeters. So here's 25 centimeters. Now, something we learned from the previous question that we did, if we want to calculate the length or the arc length, what we need is the angle. So the angle over 360. So the last time we did this question, we used 180 over 360 because it was a semicircle. Now this angle, whatever angle this would have been put over 360. Then we would have multiplied it to the 2 times the pi multiplied by r. Okay, and again, they told us here what the pi is equal to. But we know that this is equal to the arc length. But they gave us the arc length, or we worked it out rather, which is 25 centimeters. Now, our goal here now is to try and get this r, theta by itself. So let's try to break this down. So we have pi theta, over 360 times 2 times pi, which is 22 over 7. So 22 over 7 times the radius that we have, which is 18. And that is equal to 25. Now what I'm going to do is I'm going to work out all of these here, as if this theta wasn't here, just so I could get one solid number. Alright, so if I wanted to do that, let's do it piece by piece. So I'll do this section first, so you could see my process. I could do everything one time, but I'll just do this part first so y'all could see. So I'll do this part first, and then once I'm done with this, I'll handle the 360. Okay, so 2 times 22 over 7 times 18. So 2 multiplied by 22 over 7 times 18 gives me 113.14. So that's what I get for this. Alright, so then I could put here now theta over 360. So I have this here over 360 multiplied by 113.14, which is equal to 25. Okay, so my next step is I could get rid of this 360. So since it's being divided by here, I could just multiply it on both sides. So once I do that, it's canceling out here, and I would be left with basically 113.14 theta, because I'll be left with theta times 113.14, which is now equal to 25 times 360. So when I do this, I'll do 25 times 360, which gives me 9,000. So then I'll get here 9,000. Now, to get theta by itself, that means I have to divide both sides by 113.14. So if I divide both sides by 113.14, that would be leaving me with my answer. So then theta would be equal to 9,000 divided by 113.14. And based off of this, my answer is 79.55, because this 7 would allow this 4 to round up. So 79.55, which is approximately 80 degrees. So this is how I just proved that the angle here is approximately 80 degrees. Anybody got that? And then after, we'll try to work on calculating the area enclosed by the wire. Alright, let's try the area now. So since they already basically gave us a value for this, or the angle, I'm going to use that value, which is the 80 degrees here. So just to let me see, just to sketch that out. Alright, so we have here 80 degrees, and we have 18 centimeters as a radius. So I know that the area of a sector is going to be the angle over 360 multiplied by pi r squared. So I could say the area here is 80 over 360 multiplied by 22 over 7 times 18 squared. Alright, so now I could put this in a calculator, especially if I have a fractions calculator. I could just go one time. So I could say 80 over 360 times 22 over 7 multiplied by 18, which is the radius, squared. That gives me my answer. So just to verify again, the angle, which is 80 over 360 times 22 over 7 times the radius, 18 squared, which gives me 226.29. This 5 would make this 8 raised to a 9. 226.29. So that is my area. So remember, even this question that we did before kind of used that same concept to some degree. Because remember, we had to use the area at this point here, which was 180 over 360. So the angle over 360 times pi r squared. So we come here again, same concept again. The area of this, the angle over 360 times pi r squared. Same exact concept. Alright, so let's see what y'all would do for this one here now. Okay, so remember, this again is a similar concept. Calculate the length of the arc AB. So it's a similar concept to what we was doing before and so forth. So we use that over here with the particular angle over 360 times 2 pi r. So let's see what y'all will come up with over here. Let's try it now. So BI. So with this one, BI we have to calculate the length of the arc AB. So this is the arc AB. So if I was to draw this out, this is what we're looking at. Okay, so this is the arc here, and this is 12 centimeters. Now, the formula to find the arc length comes from the circumference of a circle, just that we are using the proportion that it carries. The circumference of a circle is 2 pi r, but the sector, the arc for a sector, is just pi over 360. So that proportion of the full circle, so the proportion of this full circle is 18 degrees out of 360. So it's not a full circle, it's just 18 degrees of it. Multiplied by 2, multiplied by pi, which this question told us has to be 22 over 7. If they don't tell us, we could use n1 times the radius, which is 12. So if I put this in the formula in the calculator, I should get my answer. So 18 divided by 360, which is the fraction, times 2 times 22 over 7 times 12 gives us the length, 3.77. So the arc length here is 3.77. So 3.77 centimeters. Alright, so they say they want us to determine the area of the curved face. So this here is a curved face. So ask yourself, what shape does this curved face form? So I want y'all to try and work that out. Give you 2 minutes to do it. What you did?
Times 3.77 by 8 centimeters.
Good. So basically, this forms a rectangle. Okay, so here's 8 centimeters. Here is 3.77 centimeters. So once we multiply these two, because the area of a rectangle is length times width, once we multiply this, we will get the area. So 8 times 3.77. So that's 30.16. So I could say 30.16 centimeters squared. That's my area of the curved face. Now the next one, they say given that the area of OAB, so the area of OAB is this, right? So remember, for a 3D shape, a 3D prism, we should say rather, the volume is equal to area times the height. Okay, so let's say we had this shape. Now this is considered a prism because we expect this cross section to be the same throughout the entire shape. So it kind of looks like a, if you was to cut these in pieces, all of them would be they would look like slices of a cheese on top of each other. So if I know the area of this, I could work out the area of this if I don't have it, work out the area of this, and then multiply it to what we have here to get that particular instance. It doesn't matter how the shape is torn, we just need to ensure that for the prism, if I cut it going in that direction, it's going to be the same. So with this, you may have to think about how I'm cutting this to make sure it's the same everywhere in order to help you to find this out. Okay, so let's see what y'all do to get this particular answer. So the cross-sectional area they're saying here is OAB in this instance, right? So this here is a cross-section. So if I had to set it up like this, it's almost as if we had that standing up there and we extend it and it came over here, all right? So it's like this cheese here, which is this part, and from here to here is 8 centimeters. So this here, I just flip it, so I make it standing up. So this here is standing up, all right? So in essence, since this is the area that we know, which is 22.6, which is here, using this same principle here, I would say that the volume is equal to 22.6, which is the area cross-sectional, times this distance here, which is 8 centimeters, okay, which is right here. So then that would give me my final answer in centimeters cubed, because that's volume. So 22.6 times 8, which is 180.8. So 180.8 centimeters cubed. Okay, so remember we also learned the other day that this is the same as milliliters. So even if I wanted to convert this to milliliters, 180.80 centimeters cubed is the same as 180.8 milliliters. So they didn't ask us to do this in this question, but I was just showing it to you for reinforcement. All right. So therefore, if you wanted to convert this to liters, we just divide this by 1,000. So they said the cross-sectional area of OAB. So the area of OAB, okay, and remember it has to be like a same section throughout. That's why they say the uniform cross-section of a slice of cheese. All right. So if you think about it, this is like a bunch of triangles sitting on top of each other. So there's the same straight to the bottom. That's why we look at that as a cross-sectional area, then multiplied by the height, 8. Make sense now? All right. Okay. So let's see what y'all come up with. So for this one, it says the diagram below shows a gold bar in the shape of a trapezoidal prism. The volume is 2,886. The length and the height of the prism are indicated on the diagram. Calculate the area of the shaded cross section. So this is a shaded cross section of the trapezoidal prism. Okay. So remember what we said the volume of a prism is. It's applying the same concept from what we did earlier. So volume is equal to area times height. So let's see what y'all gonna come up with. And remember, when we talk about the area times whatever height, it's the height relative to this cross section that we're looking at. So wherever the cross section is, you're looking at a perpendicular height from that. All right. Now bear that in mind whenever you're thinking of that. Figure out for yourself. If I chop this up in pieces, will it be the same size as if I cut, depending on where I cut? Okay. So remember volume. All right, let's go through it. So it says volume is equal to area times the height, right? So the area is what we're trying to figure out. We have the volume. So the volume V is equal to 2,886. And the height that I will use is 31.2. The reason being is because if I was to cut this in slices, it would remain the same because of this cross section here. So remember what I said earlier, the cross section, the height relative to that cross section is usually perpendicular to it. Okay, it's usually perpendicular to it. So in this case, it would be this one right here. So therefore, I could substitute, replace that V with 2,886. Which is equal to A times 31.2. Now to get A by itself, divide both sides by 31.2. So that will leave me with area. So 2,886 divided by 31.2 is 92.5. So 92.5 centimeters squared would be my area for this section here. So the next part of the question says, calculate the height of the cuboid-shaped gold bar. Now, it says here that the cuboid-shaped gold bar shown below has the same volume as the trapezoidal prism-shaped gold bar displayed in A. Okay? So this here has the same volume. So what we need to figure out now is what is the height? Okay? What is the height? So what is the volume of a cuboid? How do we calculate the volume of a cuboid? And then figure out what the height is. So let's see what y'all will come up with this one. Let's try it out. So typically we know that the volume of a cuboid is length times width times height. So the length times width specifically represents the area. Okay, in this case we could use this part as the area because we're looking at the cross-sectional area. So this part here, which is 30.6 times 8.2, that would have given us the area, and then we multiply it by the height, which we don't know right here. Okay, so if I simplify this now, I'll get 30.6 times 8.2, which is 250.92. So 250.92 H. Now this volume, so this multiplied by H gives me 2,886. Now if I want to get H by itself, I just have to divide both sides by 250.92. So that's gone. So then that would give me the value of H. So H is therefore equal to 2886 divided by 250.92. So you can come here, 2886 divided by 250.92 0.92. That's going to give me 11.50, which is basically 11.5. So 11.5 centimeters. So that's the height.
I got the concept of it. No, I get it.
We're getting into some interesting matters. So it says the trapezoidal gold bar is melted down and all gold is used to make 6 identical spheres. Now, if I melt down this, it does not change the volume. So let's think of it like this. If you have a bottle of ice, a bottle of water, if the volume in that bottle of water is 500 milliliters, if you put it in a freezer and you freeze it and it turns to ice, it has changed its state, meaning it has changed from liquid to solid. However, its volume remains the same. Does that make sense?
Yeah.
Likewise, if I have a gold bar that is a cuboid shaped gold bar, when I melt it, it will give me the same volume. Likewise, if I take this trapezoidal one and it has the same volume and I melt it, it will still be the same volume. It will be in liquid form, but it will still have the same volume. So what they're saying here is that the trapezoidal gold bar is melted down and all the gold, it's a reason why they highlighted all the gold to say that, hey, we did not lose one drop, so the volume is the same. The gold is used to make 6 identical spheres. So spheres is like a ball, okay? Calculate for each sphere of gold its radius. So before we get into calculating the radius, the first thing I want y'all to do is I want y'all to calculate what is the volume of one sphere. What is the volume of one sphere? Okay, let's start with that. What's the volume of one sphere? All right, so we melt this guy here. So after we melt him, we had his volume. We know what his volume is. Now we have 6 identical spheres coming from that one volume. So I want y'all to work out the volume for one sphere and then we go from there. I'll give you 1 minute. All right, you should have it now. So what is it? How did you work it out?
I did 2,886 divided by 6.
Good, because that's the total volume and you divided it by the number of spheres that was made. So when you divide that by 6, your answer is what?
481 centimeters cubed.
So 481 centimeters cubed. All right, good. So we know what is the volume for one sphere. Okay, so one sphere is 481 centimeters cubed. Now, what they want us to do is calculate for each sphere. So we don't figure out what one is, the radius. Okay, so we know that one of these is 481 centimeters cubed. They also gave us the volume of a sphere. All right, let's see what y'all gonna do to get this. So the volume of a sphere is equal to 4/3 pi and then r to the power of 3. Let's see what y'all gonna do to solve this. All right, so let's try it now. You guys got it? You tried it? All right, so let's go through this now. So with the volume, I already have the volume, which is 481. So 481, which is equal to 4/3 multiplied by pi, which they told us is 22/7. Where did I get that from? Here. This is what they told us to use for pi, 22/7. And then what we're trying to find is r, which is to the power of 3. So the first thing I want to start out is this thing right here. So I'll say 481, which is equal to, and now I could try to simplify this from the calculator. So 4/3 times 22/7. So that's 4.19. So right here, 4.19 r to the power of 3. So how can I get r to the power of 3 by itself?
You can divide by 4.19.
Correct. We could divide both sides by 4.19. So we divide this by 4.19, and we also divide this by 4.19. So what we'll be left with is 481 divided by 4.19, which gives us 114.79. This turns to 8, so 114.8. So I could say 114.8 is equal to r to the power of 3. Now the thing is, r to the power of 3 is not r. So the opposite of cubing is to cube root. Okay, so we cube root. So if we cube rooting would mean instead of squaring, which we use a 2, we'd have a little 3 here to cube root. So in essence, r would be equal to the cube root of 114.8. So cube root just means what multiplied by itself 3 times is going to give me 114.8. So for here, we have the n cube root. So you might see that on your calculator. So you could put 3. And then this here, let's see. So I put this, but I want n here, which is 3. Okay, so then now we could 114.8. So the answer is 4.86. So it's telling me that my radius is 4.86 centimeters for each sphere. All right, anybody got that answer?
Yeah. Yeah.
Lovely. So if you don't have it, take it down, and then we'll try the next one they want us to do. They want us to do 2 more, the surface area. So the surface area of a sphere with radius r. This is the area they give us for the sphere. And then they want us to find the mass to the nearest kilogram, given that the density of gold is 19.3 grams per centimeters cube. Okay? And remember, we are doing this for each sphere. So not all of them together, just each. For each. So you guys work out surface area. That should be a straightforward one. This is I. What we just did here is for I. Now we need to do I. So if I was in an exam and I didn't get the answer for the first one, I would still just use a value to try to show that I know how to calculate this, as well as something for this too, you know? You just want to show that what was stopping you was the answer. So whatever answer you end up getting here, even if it was wrong, it still apply to the next concepts to show that you know the thought process, you know what happens next. All right, so let's see what y'all get for the surface area. That should be a quick, easy one because they gave us the formula. So I'll give you all 2 minutes to do that one. And once you get that, you could jump straight into this here. So it says the surface area is equal to 4 times pi times r squared. So what I'll do is 4 times the 22 over 7 multiplied by this 4.86 squared. All right, so when I work that out, times 4.86, the square. So 296.93. You guys left it to 2 decimal places?
Yes.
Lovely. All right, good. So we're on the same page then. All right, so I give y'all a chance to try it. So let's look at it. Let me see if I could give you a little heads up. So it says the density of gold is 19.3 grams per centimeters cube. Now it says we need to find the mass of 1, but we have the volume of 1 already. So we know what the volume is of one sphere. What's the volume of one sphere?
481 centimeters cubed.
Good, centimeters cubed. So we have the volume, we have the density. All we need to find is the mass. So if you're looking at this here, because the mass says, the density says grams per centimeters cube, When I find a mass, my mass is automatically in grams. Okay? So based off of this, I know that the density is this. I know that the volume is this. So if I was to replace that in the formula, I would replace density with 19.3. So let's just put the formula here so you could see. M over V. So density is 19.3, which is equal to M over V, which is 481. Now, we could cross multiply, but we just put this over 1. Our good friend cross multiplication. So 19.3 times 481. So 19.3 times 481 is equal to M times 1, which is M. So I can work this out. 19.3 times 481, which is equal to 9,283.3. And this is in grams. Okay, so my mass is 9,283.3 grams. But they want this in kilograms to the nearest kilogram. So all I have to do is divide this by 1,000, and that will give me my answer, which would be just 9 kilograms. Now, the reason why I said 9 kilograms is because they told me to the nearest kilogram. So if I really was to work this out, I would get 9.2833 kilograms. But they say they want it to the nearest kilogram. Okay, so that's why I just dropped it to 9 kilograms. Does that make sense? Alright, good. So, guys, all this is, right? Y'all at a stage now where you just gotta like practice over topics that you're struggling in. The best way to get better is practicing the actual questions and then trying to figure out the answer. You know, so just look at the question, try to figure it out, get the answer, and try it over again. So these questions that we did, do them over again. Once you do them over again, it reinforces why you learn and it reinforces why you missed. So therefore, you get better at identifying that again and just getting stronger in using whatever tools or formulas you use to get to that particular answer. All right, so that's what it is. You guys got 16 days left. Trust me, you got time to make this happen. Okay, trust me, you guys got the time to make this happen. But you got to ask yourself, will I make it happen? That's all you got to do. And you just got to make it happen. All right, so guys, keep going through this stuff, keep practicing, and stay focused on that goal. Okay, have a lovely day. All right, see you. Bye.